Good evening, class. My name is Lakeisha Joyner, and my topic for LSIS 524501 is toxicology. And I want to start by giving you a little bit of history of toxicology. The history of toxicology dates back to the early humans who used animal and plant poisons for hunting and warfare. And the poison of choice during this time was actually hemlock. And hemlock comes from a plant. And it's actually the budding of the plants that was the poison. So if it was ingested, it would kill you. So the Greeks circa 1500 BC used hemlock as the state poison as well as opium, aconite, and heavy metals such as lead, copper, and antimony. Hippocrates, circa 400 BC, introduced clinical toxicology principles by describing elemental concepts of bioavailability and overdose. And Dioscorides, a Greek pharmacist, made the first attempt to classify poisons. And a little bit of the history that's we're going to continue to talk about. Socrates, 479 to 399 BC, was poisoned by drinking hemlock. Is one of the best known cases of execution by poisoning. Okay, and during the Middle Ages, the use of poisoning was very important. During this period, the use of poison was a common way of eliminating political contenders, spouses, and competition. And following the Middle Ages came the Age of Enlightenment, in which the field of toxicology was advanced by scientists. And Paracelsus, 1493 to 1541, is considered the father of modern toxicology, describing the principle that dose makes the poison. And during the 19th century, and with the rapid advent of organic chemistry, many new chemical compounds were synthesized. This gave us a new shift to the science of toxicology, as it was necessary to test the newly developed compounds for its toxicological properties as is done today. Finally, during the 20th century, toxicology quickly developed into the multidisciplinary field. So, as you can see, during the 20th century, toxicology has branched out 20th century and beyond. So now we were talking about toxicology, but let's get a definition. Toxicology is the study of poisonous chemicals, drugs, etc., and how a person or other living things react to them. It's also a science that deals with poisons and their effect with the problems involved, such as clinical, industrial, or legal. So that's the definition of toxicology. Next, we have the different types of toxicology, and the first one should be chemical. So, chemical toxicology is used to understand and determine the properties of harmful chemical agents and to learn the nature of their toxicity on a chemical level. And next, you have toxicogenomics, and it focuses on the molecular profiling of toxins. Next, you have aquatic toxicology, which deals with the effects of natural and manufactured toxins on aquatic life. Then you got ectotoxicology, which focuses on the effects of synthetic and natural pollutants on all biological life. Further, you have environmental toxicology, which focuses exclusively on the effects of pollutants on the environment. And we've all seen CSI or NCIS. So forensics plays a big part in toxicology. So forensic toxicology helps determine details in criminal, medical, and drug-related analysis. So those are the different types of toxicology: chemical toxicogenomics, aquatic toxicology, ectotoxicology, environmental toxicology, and forensic toxicology. Next we have toxicity, and it's a degree to which a substance, a toxin or poison can harm humans or animals. Now there are three types of toxicity. Your first one is acute toxicity, which involves harmful effects in the organism through a single or short-term exposure. Subchronic toxicity is the ability of a toxic substance to cause effects for more than 1 year but less than the lifetime of the exposed organism. And last, you have chronic toxicity, which is the ability of a substance or mixture of substances to cause harmful effects over an extended period of time, usually upon repeated or continuous exposure, sometimes lasting for the entire life of the exposed organism. So 3 types of toxicity: acute, subchronic, and chronic. Now this is very interesting and very important. These are the top 10 deadliest poisons known to humanity. And number 10 is cyanide. It's known as a life-taking chemical. When it enters into the body and it gets binded with the iron in your blood that is present in the blood cells, it prevents the circulation of oxygen on the body. And we've all heard of anthrax, and that's in the news. So if that's inhaled or ingested, swallowed, it's going to block the respiratory system. Nerve gas, or sarin, is a very dangerous and deadly nerve gas. If inhaled, death can sometimes be caused within 60 seconds. And an example was the nerve gas. This nerve gas was used in a terrorist attack on the Tokyo subway. It did not give the year, but this has happened over in Tokyo. Number 7 is amatoxin. And this kind of poison is present in some dangerous mushrooms. This poison attacks directly the kidney and the liver of the human body. Number 6 is strychnine. So this poison is an odorless white powder, sort of like anthrax, which is extracted from some trees in Southeast Asia and India. This poison can be given orally or it can be inhaled. It is the bitterest of the substance to human beings, and only a small amount of this poison can cause death. And number 5 is mercury, and mercury is found in fish, but it has very low levels. But a single drop on a human hand can cause attacks on the nervous system and the lungs. And so continue, we are on number 4. It's tetrodotoxin, and this is found in pufferfish. And this poison can be found on the skin, intestine, and liver of the fish, and it causes mental implantation and paralysis. Number 3 is ricin. It's extracted from the castor bean. Ricin can actually stop the protein production in a human body, which is essential for the human survival, and the person goes into shock if they come in contact with ricin. And many countries started using this as a weapon. So number 2 is VX, and this is the most dangerous nerve gas. And it was initially marketed as a pesticide, but was soon banned because it was very dangerous to humans, and a single drop on a human skin can be fatal. Many countries started using this like a weapon in world wars. And number 1 is botulinum. When humans come into contact with this poison, within seconds the nervous system will shut completely down. So these are the top 10 deadliest poisons known to humanity. Now, ToxNet, and this is the Toxicology Data Network. And ToxNet is a, excuse me, get focused. Okay, ToxNet is a group of databases or a data network, and it covers chemical and drugs, disease, and the environment, environmental health, occupational safety, and health poisoning, risk assessment, and regulations and toxicology. And it is managed by the Toxicology and Environmental Health Information Program. So I want you all to see this slide. And it's the Division of Specialized Information Services, which is SIS. It's of the National Library of Medicine. We have talked about this a lot in class, the National Library of Medicine. So this database is very good. And this is a trusted source. So one thing when you're doing your research, you want to always make sure it's a trusted source. And ToxNet provides links to PubMed, and it's a NLM's free web interface to the world's biomedical literature and to additional sources of technological information. So we're going to continue on. I just want you all to see the slide. I'm trying to get a view of the information. Okay, now that's the ToxNet, and it's Toxicology Data Network. Next we have Chemical Nomenclature and Structure, and this is Chem ID Plus, and it contains over 400,000 chemical records. Now, more than 300,000 of those records include chemical structures, and it's searchable by name, synonym, CAS registry number, molecular number, classification code, locator code, structure and or physical properties. And this is Chem ID Plus. And now you want to come to your toxicological data. We're still on this. And so our first one is CCRIS, and it's chemical carcinogenesis. Focus on the slide so you all can see it. So it's chemical, and I'm sorry for the